Okay, so we have looked at the purpose, at the statistics, and of the requirements. What about the robustness? I mentioned that the test has quite a few assumptions and requirements, and many of them will not actually work in practice in many situations. So this is where it is very important to ask, is this test actually robust? Can it handle variations from what is expected? And the answer is yes. This t-test, as I said at the beginning, is very robust, especially if the sample size is large. The larger the sample size, the more stable the test is, and the more robust it is, and the more reliable therefore it is. In fact, you may see in your articles some mention of something called the Z-test. And what a Z-test really is just a t-test done on a large sample. I'm going to stay away from discussing why the difference between the t-test and the Z-test names. Just keep in mind that this will happen. So if you hear somewhere talking about a Z-test, keep in mind it's pretty much just like the t-test. Now, for those of you who are really statistically inclined and knowledgeable and so on, you may contradict me on that, because some people do make a differentiation between t-test and z-test in the sense of what they do and what the requirements are and so on and so on. But for all practical purposes, really in life, there is no such thing as the z-test that the statisticians have in mind. People always use the t-test from the technical point of view. They just call it the z-test when you have a large sample. All right. Now, the requirements are never fully satisfied, however, remember. Okay, so even though the test is robust, okay, we have to keep in mind that the p-value should always be considered as approximate. This is a fact of life that should be kept into account for any test, but it's particularly important for the t-test because of the reliance that many people have on it. Many people rely on the t-test as practically the golden rule of tests, and because of that we have to keep in mind that its p-values are not sacred, they're approximate, and so we have to interpret them as such. In particular, when the p-value is a borderline p-value, very close to the significance level, then we want to be careful and not jump to hasty conclusions. Now, if, however, the requirements are really badly violated, like we're testing something where the shape of the histogram is definitely not a bell shape, it's very skewed, and the sample size is not large but it's reasonably small, and so on and so on, that in that situation maybe a different test should be used. So this is one of those situations where becoming stubborn and wanting to use the t-test no matter what becomes counterproductive, and it can be actually dangerous. Now, the title for this class was t-tests in the plural. So why is that? Are there several such tests? Oh, yes and no. Yeah, there are more than one, but they're not that different from each other. The number crunching part is very similar, but there are a few variants. Okay, so what variants are there? Well, first of all, depending on whether we're talking about a one sample or two sample or matched sample, then we have a corresponding t-test. As I said, the idea is still the same. It still uses sample size, sample means, standard deviations, but which ones and how are they combined and so on, that changes a little bit from one situation to the other. Okay. Also, of course, there is one-sided or two-sided t-test. It can be used in both cases. As usual, the p-value for a one-sided test is going to be half of what it would be for a two-sided test. Okay, but we can use them both situations. Also remember that I mentioned that one of the requirements is that the variability into two groups that we're comparing, if we're comparing two groups, should be the same. Well, what if they're not? Well, then we should use something else. There is another test that is very similar to the t-test. It works very similarly, the number crunching is very similar, and so on, that can be used when the two variabilities are not the same. However, this leads to an approximate, to a further approximation. Okay, so there is an approximate t-test that allows us to compare two groups with different variability. So that's another kind of t-test. Alright, so what if things go wrong? What are we going to do when things go wrong and some of the basic assumptions and requirements of the t-test do not work? So once again, If the requirements are not satisfied, well, keep in mind that there are other tests. Other tests exist that can allow us to ask similar kind of question about averages and comparison of averages, but do not require what the t-test requires. So if we're really dealing with two populations for whom the distribution is really not bell-shaped, then we should use something else. We shouldn't get stuck and insist on using the t-test. Okay? So what if a t-test was used inappropriately? Okay, so if you read an article and you realize that, boy, they went ahead and used the t-test, but that wasn't really a good idea. They should have used something else. Well, in that case, what you want to do is you want to be careful with the conclusions. You don't want to trust them entirely. Now, it doesn't mean necessarily the conclusions are plain wrong. They may still be correct, and they may still be acceptable in some situations, but you don't want to go wholeheartedly and trust them. Finally, what if we need to compare more than two groups? Remember, an important point about the t-test is its purpose. It compares two means, right? It could be one mean of one population to a fixed number, okay, no problem, or it could be comparing two populations. What if we want to compare three or more populations? Well, in that situation, you cannot use the t-test. You have to use a different kind of test, and we're going to look at that particular test next time.